Hello, my name is Izumi from Yahoo, Japan. Today, I would like to talk about measures to address the load to Yahoo Japan shopping app. Let me introduce myself first. My name is Akinori Izumi. In 2012, I joined Yahoo Japan after graduating from college, and since joining the company, I am in charge of Yahoo Japan shopping service. At first, I was a web engineer of the front-end system, and after that, I was doing back-end system and system operation. And after that, I became manager, and now I am doing applications. Fortunately, from front-end to back-end, in Yahoo Japan Shopping, I was able to do a lot of different systems, and in 2019, I became a system general load manager. And right now, I am the head of department responsible for the native applications. This is the overview of this session. Super sales place a high load on the system. So in this session, I would like to introduce the load measures, load balancing, and efforts related to the loads on Yahoo Japan shopping app. Here is the agenda for today. First, I would like to introduce to you what Super PayPay Festival and the difference between client applications and server-side applications in terms of how to develop applications. And then I would like to talk about load balancing for Yahoo Japan shopping app and how to prepare for the unexpected. So first about Super PayPay Festival. So what is Super PayPay Festival? This is a large-scale campaign measures to be held simultaneously offline and online using e-commerce shops, and Yahoo Japan Shopping participates in this campaign. So this is a great campaign period. You can save money for this shopping. However, the traffic because of this system is going to increase drastically. So we have an exclusive team for load balancing. And we have countermeasures for all the applications that include these festival applications. So in this November, this Super PayPay Festival is going on, currently being held, and Yahoo Japan Shopping has a big promotion, especially the last days, 2 days of the month. Yahoo Japan Shopping has a big markdown activity, so please join us to this Super PayPay Festival. This is a very big super sale activity, and I would like to talk about the impact of this kind of super sale on the app. This graph shows the communications from the applications, and y-axis is communication, and x-axis is time from 0 hours to 23:59 hours. And the blue graph, the blue one, the line is the load of the days of the festival, and the gray is the load in ordinary days. As you can see during the sale, throughout the day we have a lot of requests. Especially as soon as the sale starts, drastically the load increases. Sometimes it becomes more than 10 times as much as the ordinary days. So next, I would like to talk about the impact on the app. These are the actual trouble of applications because of the high load. Because of the high load, there are some failures in the applications sometimes. The native functions had to be suspended, and the top page module could not be displayed due to high load. And also, the major functions had to be stopped on the app that troubled the users. In Yahoo Japan shopping service, we have to be ready for this kind of high load and the drastic increase of the load. So every day we take countermeasures against them. Next, coming back to the agenda, comparison with server-side applications. So how is it different to develop applications on server-side and client-side? We have server-side applications and client-side applications. And for each of them, execution environment for applications is very different. And for server-side applications, we have remote implementation of the applications. And for client-side applications, users' devices run the applications. High load sometimes lead to some trouble. And when we have real-time troubleshooting, how to troubleshoot is different for each of them. So I'd like to compare those. First, about the server-side application.
Now, what you see here is a very general web application system structure. When there is an access to the front-end server, then in order to retrieve the data, API server will receive a request, and API server will send a request to the database where the data resides. Now, the entry point for these systems are the front-end servers, and let's say that server receives tremendous amounts of access. So a huge amount of access is generated, and then all the server-side applications will go through high load conditions. And there will be certain issues or faults or failures. And in order to address the high load on the server-side applications, there has to be, for example, corrective operations and releases issued. So how exactly is troubleshooting done? As you can see in this diagram, the reinforcement of the resources as well as the fixing of the programs, recovery of the data are some of the measures undertaken. But all these efforts are done on the server side. And once all the work is over, then the issue itself will be resolved. So for server-side applications, everything will be handled within the server side. Now let's take a look at the client-side applications and how troubleshooting is done in the client application. So this is the configuration, and Yahoo Japan shopping load balancing is what we're talking about. And so let's assume a smartphone native application. So from the native application, there's a request to the API server, and API server sends a request to the database. Again, let's assume that there was a huge amount of access. As in the past, there will be high load leading to some faults or failures in the different systems involved. So what are some of the troubleshooting measures we take? For the server side, earlier I said that to deal with the high load, there are various measures such as correcting or repairing the programs or taking certain operations. However, when it comes to native applications, we cannot do this program fix immediately. The reason is, as you can see in the following slide, for native application, after the correction is done on the program, Appli Store has to receive an application for screening. And after the screening, and if it's accepted as acceptable, then it has to have an update of the application on the user's terminal. So user has to take the initiative of updating it. In other words, and as long as the user doesn't do the updating, the failure will remain with that device. So unlike server-side application, client application correction or repair timing cannot be controlled from our side. In other words, we have to be careful for taking some immediate and emergency measures. On the side, I will for Yahoo Japan Shopping application, we need to go through this application and screening process. But in some cases, it took 2 weeks or more for that screening to be completed. And so if there is a problem, then there's a possibility of the impact being felt in a wider area. So I think this is one possible major risk for application development. Now, I just mentioned how difficult it is to take some immediate and emergency measures for native applications. Now, with regard to Yahoo Japan Shopping application, if there's any load-related failure, can we not do anything? Well, no, we can. Let's say there is a failure, and then we can actually notify the users. And also when there is a fault or malfunction with some of the modules, then we can hide the modules or we can change the order of certain functions. However, emergency releases or access control by the application have not been possible, unfortunately, because it is a client-side application. So these are some of the challenges that we face, and there are two. First, I'm repeating myself, but update by the user is necessary for the response. And so emergency release is not available, and then without the updating, bugs will remain with that device. And the second point is the application engineers will be on the sidelines. What I mean by that is Yahoo Japan Shopping, especially when the load is increased during the day. Of course, for hours of the day where such a high load is expected, we have people on standby. However, because of some limitations, even if engineers are on standby, there are actually limited measures that the engineers can take to address high load. And therefore, server-side engineers had to be called on to support us. So these are the challenges that we had. And so we have these issues and also limitations, such as asking for approval. But let me now turn to the load-related measures that Yahoo Japan Shopping application has been taking. So this is, again, the same system configuration that I have shown you earlier. Now, the access from the Yahoo Japan Shopping application can be seen as an API call, and we focused on that. And we introduced a mechanism where API communication can be controlled from the outside.
So here is how it works. So first of all, to call API or not, this on-off information is described by the external file. And we have this external file, and that is read from the application to check the settings. Instead of the applications, we have new application judgment logic that makes a judgment of the requests. So those requests who are not judged as okay, they are not sent to the API server. Only approved requests can go to API servers. In this system and configuration, only the app can do access control. So when there is a concentration of the access on the app, we can block certain communications. It's not only on and off of APIs. In the setting items, we have frequency of the request and the number of errors. So for example, when the number of errors come to a threshold, we have a system to reduce the number of requests for a while. So only on the app we can implement such kind of functionality. This external file with this API setting information can be updated freely by the app engineers. So when there is a high load situation and when they want to block a certain API communications, we can just change and update the files. So on the real-time basis, we can control the requests to API. Here is an external file and the contents. This is a very simple JSON array. The names of the host and paths and requests, frequency, switch on and off setting can be seen. As I mentioned before, when the number of errors come to a threshold, we can block APIs, and this is the limit value we are using for that. In this example, when a certain error number comes to a threshold, we can block the API communication for 600 seconds. And if you want to uniformly block certain API communications, you can use this EMG equal true. So you can uniformly block API communications. Here's a description of multiple host names and API settings. So almost all APIs can be controlled that come from the app. By having load balancing, we were able to implement all of them. We have following three. The first one is switching APIs remotely. Without any special release, we were able to do it. Number two, introduction of circuit breaker. I talked about limit parameters, and by updating to these parameters, when the number of errors come to a threshold, we can block API communication for a certain period. So this is the role of this circuit breaker. Number three, benefits to server-side engineers. This was a challenge before. We had to request server-side engineers for load balancing. However, on the app side, we can do it. So we don't have to ask server-side engineers every time. So we can reduce the workload of the engineers. This is the next agenda. This is about to prepare for the unexpected.
The access control on the application side is implemented, but regardless of the amount of preparation, there can be the unexpected. There might be some high load or unexpected trouble. And so to prepare for that, Yahoo Japan Shopping has several measures that we have prepared. So Yahoo Japan Shopping application, when there is a malfunction or failure that impacts the entire application features, we have a web view page opening function. So this is for emergency. So although limited, certain contents can be shown on the web view. And it is a simplified kind of view. However, we can still avoid any confusion amongst the users by showing this rather simplified web view page. And so rather than this blank page with an error message, I think it would be much better. And this is just in case. Of course, this is not expected to be mobilized so often. Now, next, I'd like to talk about the merchandise page. In the Yahoo Japan Shopping, there's a merchandise page, and under normal circumstances, a native application actually does the rendering of the page. However, calling certain APIs or several other processing happens, and if they face some errors or issues, then automatically the web view page will open to show the merchandise detailed page. The left-hand side shows the normal page, and the right-hand side is the abnormality, which is the web view page that kicks in automatically. So when there's a trouble, this actually comes in automatically to show the merchandise page. So it's a safety function or feature for the page. And in daily activities of development, we are checking the durability of individual modules with regard to load, and we also assume what measures to take in case there's a high load. For example, as you can see in this table, there are multiple modules, including campaign, ranking, order history, view history, and coupon. So there are these modules, and for each of them, we look at the durability against load. Let's say the campaign module and ranking modules may be durable against load, and then maybe the responses may not be that necessary, or maybe we can switch to cache versions. So these are some of the measures that we have been thinking of taking. However, relatively weak against durability load is, for example, the view history and coupons, as well as order history. And for these modules, when there's a high load situation, then the simplified versions will be used for display, or there might be a switch over to a different module, or static modules will be used instead. These are some of the measures that we have. Of course, we have these ready, but they're not used so often. But still, we design the application so as to be able to use those functions when they are needed. Finally, this is the summary, the conclusion. So this time I have been talking primarily about load balancing of the applications. And therefore, I'd like to talk about my idea of the mindset that application engineers should have with regard to load. First point is that load balancing is something that should be taken as a given by application engineers, because we're talking about applications that the users come in contact with first. And so application engineers need to think about those users and the possibility of failures or troubles that the users might have. And therefore, the application engineers have to assume certain situations and then have measures ready when such situations arise. And the second point is modules should be designed assuming an abnormal situation. We are engineers making products, and we are engaged in daily development work. And of course, we have multiple tasks and projects, and we are developing different modules. And for each of those modules, we need to think of how to address high load situations and then come up with measures, countermeasures, as well as ways to go around that situation. We talked about different modules. Let's say those different modules have a high load situation, then we should be able to tell, okay, we can take this measure in this situation. In other words, without that kind of assumption, when the actual high load occurs, you might actually be in a panic. You don't want that. So it's important that you have such measures ready. And the third point, backend system has to be understood well. In countering high load of on applications, we need to really have an understanding not just about the application itself, but also the backend system as well. From the application, of course, it will come into contact with API, and you have to think about the API as well as what is behind the API, and also where the API communicates with. In other words, the entire system configuration, the different pieces involved, should be understood in thinking of load balancing. In other words, a load-based or load-related measures only on the application is not enough, because application is connected to different parts in the configuration. So roles and the different responsibilities of the different components in the configuration should be understood. Finally, I mentioned 3 pieces of the mindset that an application engineer should have. And as I said at the beginning, access control mechanism has been implemented, and it is in the production environment in the Yahoo Japan shopping application. And we had experienced multiple Super PayPay festivals, among other major campaigns. and requests from the application have been requested to be reduced in some cases. And in such situations, access controls mechanism was used. And in one situation, we were able to successfully reduce requests by 10,000 RPS. So access control that I just explained is one of the achievements that we have made. And you might think that application cannot do anything about load. However, that's not the case. You can take some measures about load on the application side. So please do consider that. This concludes my presentation. Thank you very much for your kind attention.
Izumi-san.
Mr. Izumi, thank you very much. So from here, we'd like to have a plus talk. We would like to focus on the points of the people who have questions, and we'd like to have discussions. As much as possible, we would like to take up your questions as well. So if you have any questions, could you please use the question mark button on the screen? Please send us questions. Ms. Ikuko Hiraga is the person who asks questions. Line Live server-side development. My name is Hiraga. Very nice to meet you. So, Ms. Hiraga, listening to this session, what's your impression? So my impression first, for services with apps, when you release apps and when you have bugs, but you can't fix the bugs immediately. So I understand the trouble, but you are using this external file. That is very interesting. This external file, I'd like to explore more. Could you please elaborate on this? Could you please elaborate on how to use it? For example, when you have high load situation, what API should be blocked? So when you have high load, are you going to block the API with very high load, or are you going to block APIs without any important functions? Yes, thank you very much for the question. Toward the end of the slides, I said we reduced the requests over 10,000 requests per sec. So we had a lot of APIs. So which APIs should be blocked? We were thinking about it, but we have priorities. So according to the prioritization, we lined up the requests and we selected APIs without any big influence, even if we block them. That's the criteria. For example, on the screen, you have APIs, and we see less prioritized APIs, and those are the ones we start to block first. So that means, so those APIs which are blocked, so with all URLs, do you block them? Yes, all of them are not displayed. Thank you.
そうですね。
And have you actually used this feature in a real situation? Has there been any actual experience of using it? Yes, I touched on it briefly. A major sale occurred, and not just the application, but Yahoo Japan overall traffic was quite increased, and communication amongst or between applications were quite frequent. And so the resource needed to be reduced, and upon that request, we actually tried to reduce that traffic. Okay. So you have actually used it in real life. Okay, thank you.
が来ていて、
We have one question here about this external file. The load of this external file is not going to be higher. For example, the review and validation, when there is a concentration of this external file view, what's going to happen? Yes, as for the external file, on the file server, internally we have uploaded. And this is a static file, so as for the load doesn't become higher. And from the app, they obtain certain information with certain interval, and it doesn't go to look at the file every time, so there is no concern about the high load of this file. To update this file, as I have shown before, for updating. We have an app engineer to do it. This one. And of course, we cannot freely update the file. We have double checking function. And before uploading to the production environment, we have a testing environment to check the behavior and to prevent any trouble. Thank you. Thank you.
そうですね。
Another countermeasure, I would like to ask a question on Yahoo Japan shopping application default response. User has to update it, otherwise the bug will stay with the device. You explain that. That's a problem. Line Live development is what I do, and in Line Live, pop-up is actually shown, and only the ones that have updated the application can use that application, the pop-up. Is there such a mechanism with your company as well? Yes, this forced updating mechanism is available, so we can actually force update. It is possible, but pop-up is shown, and then the users might be stressed or feel stressed, or older OS may not have been used, but support OS might have been used, and then those users might be excluded. So we have to really be careful in selecting the right conditions. You cannot really mobilize this measure every time you have a trouble.
に関してすごく
And about web view, it was very interesting. So there's a question about web view. With native app, with trouble, when you use web view, you don't have any trouble. What is that? Is that because of API or native app related trouble or failure? So, yes, as for the system configuration on the app side, native app related system is here. And also there's a, if only native app is in trouble or failure, yes, that should be a failure only for the native app, or because of the high load, there's trouble. So that means we open web view, and of course, both of them could have high load situation. So in that sense, when you open web view, well, it gives more high load to web view. So there's a system to prevent that. So only native app has some trouble because of the high load. Did you have any example? Yes, only on native app. Yes. So we opened web view. That was the countermeasure we took to avoid the situation. Could you please elaborate on that? In the past, when we had a super sale, because of the high load on the app and the specific failure at the time we discovered on the app, and there was a suspension of a functionality, there was a suspension of certain features. As I mentioned before, on the right side, we stopped major functions because of the trouble. There was a promotional event, the timing of which, well, at the time of the start, all users at the same time opened the app that was really at the high load. So unfortunately, the major functions on the app stopped because of that. So that means app and web, and they were using different APIs, and the APIs only for the app kind of shut. Yes. So rather than UI problem, server API and was a problem. So you are using web API. Understood. Thank you very much.
はい
And going back to web view, in Line Live, external update from the external side, well, actually has web view already, included, or it's the web and native. You implement them thoroughly is what I understood as how you approach it. Or do you focus more on native applications, or are there pages that are unique to WebView only pages? Well, WebView and native, of course, the development cost or burden will be double. So it's not all pages that have those dual approach. we have to think about the efficiency of development and productivity as well. So we can say, okay, this page is better with web view, and it shouldn't be so inferior to native. If that's the decision, then we can opt for web view only. But having said that, for major path, so to speak, the speed of displaying the page has to be considered as well. And in some case, of course, native is faster. We have such cases. So we compare the benefits between the two and implement accordingly.
えっと
One more question about web view. There is an implementation for charging for web view. So through app you charge people, or through web you charge. What's your countermeasures against that kind of complexity? Thank you very much. In Yahoo Japan service, we have subscriptions, Yahoo Japan Premium, monthly subscription service. And on the app side, we cannot have unilateral functions for the web. But when you use app for this function, we have to make sure not to violate the terms and conditions of the app. So you don't display the terms and conditions, right? Yes. Thank you very much.